Hey everyone, welcome back to Physics 11. So in this video, I want to go over question number 6 from the worksheet 8.4 on electromotive force. So the question says, what is the EMF of the battery? Now in this diagram, we see that we have our EMF shown in this dotted line here, and then it shows the voltage, which in this case, this is showing the terminal voltage, because as you can see here, the voltmeter is connected on the outside of the battery. So this is the V terminal. Okay, so the V terminal is given in this question, which is 16 volt. And then we have our resistor, which is our load here on the outside, 8 ohm. The question says, what is the EMF of the following battery? Well, if you're trying to find the EMF, we're going to use the V terminal equation, which equals to the EMF minus the current times the internal resistance. In this case, it's 1 ohm. But if you're looking for the EMF, or epsilon, we're going to have to do this, right? Solve for epsilon. And we don't know the current I in this case. So this question is a little different from the previous questions in the worksheet because we're not given the EMF, right? We need to find it, and we also don't know the current. So you have to think about this for a bit. Notice here that the internal resistance, lowercase r, is in series with the load resistor, capital R, which means that in a series circuit, the current is going to be the same, right? So it doesn't matter the load, because there's only one path for the current to flow, the current is going to be the same. So you can find the current from either using the, well, you had to use Ohm's law first of all. So if you remember, Ohm's law says that current is going to equal the voltage over the resistance. Now in this case, we're talking about the total current, and this would be your total voltage over total resistance. Now in this example, you can find the current in two ways. You can either use the terminal voltage and use the load resistor only, or you can use the EMF and then use the R, lowercase r, internal resistance, plus the load resistor, capital R. Because we don't know the EMF we're trying to find, that we cannot use the epsilon in this case. So in our case, we're going to use the V terminal as our voltage and our load R here as a resistance. Okay, so in this case, this is going to be our V terminal over the R, which in this case is our load resistor. So this is our load. So that's how you're going to find your current. Okay, now if you did know the EMF, the other way you can find the current would be the EMF over the R load plus the internal resistance. Now, because again, the resistors are in series, you're gonna still get the same current. Now, we can't use this because the EMF is unknown, so we can't use this equation. So we have to use just the V terminal plus the load resistor. You can have more than one load resistor. You can have resistors in parallel as well. They don't have to be in series, but just in case you see a question like this where you're given the V terminal, in order to find the current, you have to take that V terminal as your voltage source. So anyway, we're going to find the total current using this. We're going to plug in our 16 volt over the R load, which is 8 ohm, which is going to be 2.0 amps. So that's going to be our current. So once you know your current, then you go back to your equation for V terminal, which is solve for the EMF, and plug in the values. So this is going to be 16 plus I is 2.0 times 1.0, so 16. We're multiplying 2 sig figs here, so this would be 2.0. Once you're adding, that should be a least number, a decimal, so this should be 18 volt. So that's question number 6. Now let's take a look at question number 8.